Hello, and welcome to Rates of Weathering, Unit 4, Lecture 3. We've already talked about mechanical weathering and chemical weathering, and the differences between them and how they're similar. They both break down rock, and they both do it in different ways. The rates of weathering is how fast the mechanical and chemical weathering happen, and usually they happen slowly, but there are ways to speed it up. Now, different things affect how fast a rock will weather. All right. What the rock is made up of plays a big role. Is it marble? It's going to be affected a lot more by chemical weathering and acid rain than something like granite. Climate could have a huge role. Does it freeze and thaw a lot? That would allow a lot more ice wedging. Is it like 70 degrees Fahrenheit all year round? Well, then you'll have almost no ice wedging. And topography, which is like how high up it is, plays a role too, because that can influence the climate as well. Differential weathering is the process where less weather resistant rocks will wear away first and at a faster rate. I mean, this kind of makes sense, all right? Think of it like partial melting, but without any melting going on and with rocks breaking down instead, all right? Softer minerals that are more likely to weather will weather first, all right? Igneous rocks that have lots of quartz, which is one of the harder minerals, remain basically unchanged. It's such a hard mineral, it's very resistant to weathering. Whereas other rocks that are made of sediments that might contain carbonates or other evaporates or various other minerals that are not quartz will weather away faster. So a lot of times what we can see is sometimes everything else weathers away and just quartz is left behind, because quartz is fairly resistant to chemical weathering. It's all due to the chemical structure. All right, this is a national park in Australia. All right, right here, you have all this sand. Well, these are what were once considered intrusions back when the landscape used to be up at the top of this. All right, these were once pockets of granite and other hard igneous rocks containing a lot of quartz, and all the surrounding rock, by one way or another, weathered away. And then these are still left. These are all hard igneous rocks with lots of quartz in it. And you can't really see it because they're covered in sand, and because there's sand around the rest of it, and the sand gets blown into them and sticks. But the reason that these pillars are here is because these are hard igneous rocks with lots of quartz in them that are sticking around. So composition plays a big role. What is the rock made of? All right. Rocks that have calcite, like limestone and marble, will weather rapidly because they will undergo carbonation. All right. They will turn to carbonic acid, or they will react with acids vigorously. All right. Think of when we did the Find a Rock lab and we put the acid on the limestone, and it bubbled pretty quickly. All right, same with the marble. Other other sedimentary rocks are affected by mechanical weathering, right? And that depends on how the sediment grains are held together. Shales and sandstones are not always firmly cemented together, and they can break up and become clay or sand particles. It all depends on how compacted those rocks actually are together. The sandstone that's in the room there, you can rub your hand across, feel the grittiness, and feel some of the sand break off. Another big thing that affects the amount or the speed of weathering is the amount of exposure. The more rock that's exposed, the faster it will weather. All right? Smaller rocks weather faster than bigger rocks because there's more surface area. All right? So as a rock breaks into smaller pieces, the surface area that is exposed increases. More surface area equals more weathering. All right, we're not going to worry about this paper exercise thing. All right, so the more surface area there is, the more weathering there will be. Some rocks contain natural cracks, natural fractures, and joints in the rocks, like spots where the rock makes like an angle or something. All right, these increase the surface area, especially fractures, because now you have a place where things like water and other liquids can go in. All right, they form natural channels for which water to flow, and when you have water, that leaves ice wedging as a big possibility. All right, and that's one type of weathering, and that breaks the rock into bigger pieces and exposes new surfaces. And again, you get more surface area, which means more weathering. All right? Climate plays a big role. Alternating periods of hot or warm and cold weather, freezing and thawing cycles. All right? They allow the fastest rates. That is us, where it's hot in the summer, cold in the winter, and in the in-between seasons, the fall and the spring, there are multiple instances where it gets to freezing and then thawing and freezing and thawing and freezing and thawing, and you get lots and lots of ice buildup, a lot of ice wedging, which breaks the rocks into smaller pieces, exposing more surfaces. The more surfaces, the more surface area exposed, the more weathering. Warm, humid climates, like a rainforest, also have high weathering because of constant moisture. All right, so the constant moisture is destructive to exposed surfaces, but it's not as fast. The fastest rates are alternating hot-cold areas. The slowest rates are in hot, dry climates because there's no water. All right, the pyramids in Egypt have been standing for thousands of years. They have not weathered all that much. They've weathered more lately because of acid precipitation, but so until we started throwing all of those sulfur dioxides, nitrogen oxides up in the air, there wasn't a lot of acid rain that was causing the breakdown of the pyramids and the sphinxes. So they have really withstood the test of time because hot, dry climates. There's very, very little water in these hot, dry climates, and it limits a lot of types of weathering, especially carbonation, acid rain weathering, and ice wedging. Right? Also, in very cold climates, ice wedging doesn't occur because it's always ice, so we don't see as much weathering there either. Topography, or the elevations, all right, that can play a big role, and mainly because temperatures are colder at higher elevations. So the higher up mountain you go, colder it is. As you get cold temperatures, you get more ice wedging. All right, it seems like ice wedging plays a big role in how fast stuff weathers, and it does. All right, freezing and melting of water causes lots and lots and lots of weathering. Right, in a steep slope, a mountainside or something, weathered rock can get pulled downhill by gravity, washed out of the way by heavy rains, moved, taken somewhere else. As you remove what's on top of a surface, you expose new surfaces, and again, more surface area equals more weathering. All right, anything that increases surface area will increase the amount of weathering. Here we got a rainstorm at the top of a hill. We get lots of sediment moving down the hill. They call this mass wasting, where you got all these sediments and particles moving down the hill. Now, as they move down the hill, they expose the rocks underneath. They hit the rocks that they go over, causing little tiny pieces to break off. All right, and then they get moved away, which is called erosion. We'll see that in the next lecture. All right, they get moved away, called erosion, And what you end up with are new areas exposed, more exposed area, and more weathering. Us, human activities. We like to expose rock when we do mining and construction, when we dig into stuff. We expose rock surfaces, we cause weathering. Also, while we are mining, we sometimes put strong acids on the rocks we are mining to make them easier to break up. We're trying to chemically weather it so that we can physically break it up. All right, we use other chemical compounds. At one point in time, we used TNT and dynamite to blast through rocks. Well, that blast through the rock, blasting a rock into a bunch of little tiny bits, is one crazy amount of mechanical weathering caused by us. Our recreation activities like hiking, riding all-terrain vehicles, riding bikes, anything that will expose new rock surfaces can cause more weathering. So any rock that is disturbed or broken by humans weathers more rapidly. And that is because we are exposing new surfaces, and the more surface there is to weather, the more weathering will occur. Again, same theme over and over and over again. We are not the only things that disturb rock. Plants and animals. We talked about the cute little whatever that was back in lecture 1. Prairie dog, let's go with. All right, so any rocks that's broken apart by plants or animals will also weather more rapidly. Why? More surface area. All right, break apart rock. More surface area. All right, burrowing animals dig holes. More surface area. All right, biological wastes. You're going to see a picture of bat poop in a minute. Can cause chemical weathering because a lot of animal wastes, our urine included, is acidic. Here is that guano, that bat poop. Looks like a milkshake fell on the floor. All right. Highly acidic. What it is doing, it is eating away at the rock. It's a cave, so it's probably limestone or some other kind of calcite-rich rock, which is going to react with the acid. You can see the little white bubbles. All right. And that is it about how fast something weathers. The big thing, if you hadn't caught on to it yet, the more surface area that's exposed, the faster a rock will weather. All right? Why is weathering so fast in climates like ours that have alternating periods of warm and cold day? Because there's more chance for ice formation and melting. And every time water makes ice, it expands, making cracks bigger, exposing new rock. Well, exposing new rock means there's more surface area exposed. And more surface area means more weathering. That can sum up. I could have just said that for 10 minutes over and over again, and I'm pretty much be getting the same point across. All right. That is it for Lecture 3 of Unit 4. There's one more lecture in this unit. Lecture 4, it's talking about erosion and rivers. And that's about it. So have a good night. Bring any questions to class, as always. We'll be there to answer them. And take it easy.